Okay, let's dive in. Imagine you're trying to build something with an AI, a large language model,
Right?
and traditionally you'd send your question, wait,
Yeah.
wait for the whole answer to come
The
back.
full block of text.
Exactly.
Yeah.
And only then could you maybe figure what if the model wanted to use some kind of tool, like, I don't know, check the weather or calculate something. It was buried in there.
Yeah, a bit clunky.
What if instead the model could just tell your app, like right away, hey, I need the weather for Toronto or whatever, and I need it now, while it's still figuring out the rest of the answer?
That real-time thing, yeah, that completely changes the feel, doesn't it? And what you can actually build with these things. It's a technical problem that's just gotten a lot easier to solve.
Totally.
Right.
And that's what we're digging into today. There's this really interesting development from Ollama, the platform for running open LLMs locally.
Mm-hmm.
They've just added support for streaming model responses, but responses that include these tool calls.
So the model's talking, generating text, and boom, midstream, it signals, hey, application, run this function for me.
Exactly that. So for this deep dive, we're looking at a blog post from Ollama themselves. Came out May 28th, 2025. It really gets into the nitty-gritty of how this works.
Yeah, it's our main source here.
So think of this as your shortcut. We're going to unpack what streaming tool calls really means, how they pulled it off technically, because it's quite clever. Look at some actual code examples and talk about why this is a pretty big deal for anyone building stuff with AI or just following the space.
All right, let's do it. So this whole idea, streaming with tool calling, why is it such a leap? What was the old way like?
Well, the core concept is just that the model streams its usual chatty output token by token, like you see in chatbots now. But at the same time, it can also stream these specific signals saying, I need to use a tool.
And it happens while the model is still, processing or thinking out loud.
Right. You see the text appearing, maybe some filler like think,
Mm.
and then suddenly mixed in or right alongside, your app gets this structured data, call function X with argument Y.
Okay, contrast that with before. Like you said, you often got the whole response back first. Maybe there was some JSON hidden in there, maybe not. But you had to wait for everything before you could even check if a tool call was needed. Your app was just sitting there, idle.
Which made the whole interaction feel laggy, right?
Yeah.
You ask for something complex, the model spins its wheels, spins some more, finally spits out a wall of text. Then your system parses it, finds the tool command, runs the tool, gets a result back, maybe even sends another request to the model to summarize. Lots of dead air for the user.
Exactly, lots of waiting. So the big win with streaming tool calls is just making everything feel faster, more responsive. Your chat app or whatever you're building gets that tool instruction almost immediately.
As soon as the model decides it needs it.
Yeah, often way earlier than waiting for the full response. So the app can kick off that tool action, maybe fetch the weather, while the model is still generating the text around it.
It feels much more like a collaboration almost, not just request, wait, response. The AI is telling you what it's up to as it goes.
Yeah, exactly. And it's not just one specific model that can do this, right? The Ollama post mentions it works across quite a few.
Yeah, they listed several. Let's see, Qwen 3, DevStrawl, those Qwen 2.5 models, including the coder version, Llama 3.1, Llama 4. And they say there are others too.
That's good. Means developers have options. You're not locked into one specific architecture if you want this faster interaction.
Definitely. Okay, so the techie part. How do they actually make this work? Because streaming text is one thing, but reliably catching this structured command midstream when different models might signal it differently. That sounds tricky.
It is tricky, and that's where the clever bit comes in. The challenge is exactly that, parsing token by token as it arrives, recognizing a pattern that means tool call, but that pattern isn't universal.
Yeah.
The old way, waiting for the whole thing, was simpler to parse because you had all the data, but yeah, it killed the streaming aspect for the tool call itself.
So you couldn't just, look for an opening curly brace and assume it's JSON for a tool call, because it might be incomplete, or just random JSON the model is talking about.
Precisely. You'd get false positives or errors. So the solution they came up with is this thing they call the incremental parser.
Incremental parser. Makes sense. How does it work incrementally? What's the trick?
It's actually pretty neat. Instead of guessing, it looks directly at the model's template. You can think of the template as like the instructions given to the model and how it should format its output,
Okay.
including how it's supposed to signal a tool call.
Right.
Maybe it's a special token like tool call, maybe it's a specific string, maybe a particular structure it's trained to use.
Gotcha. So the parser knows for the specific model running, like the secret handshake, It knows exactly what unique signal to watch for in that stream of tokens.
That's a good way to put it, yeah. It knows the template, so it knows the specific prefix or sequence that means tool call coming up for that model. And it can grab that tool info right when those tokens appear, keeping it separate from the normal text stream.
Okay, but what about, say, models that weren't explicitly trained with these special tool tokens? Or models that sometimes just, bang, start the response with the tool call, no prefix?
Yeah, good points. The parser seems built to handle that too. For models that might output tool calls, but maybe without that strict prefix, it can apparently recognize partial prefixes. It's smart enough to see the start of a structure that looks like the one defined in the template.
And the other case, tool call right at the beginning.
Yeah, the post mentions that can happen. If the parser sees something that looked like the start of JSON right at the very start of the output screen, it will try to parse it as a tool call. But, and this is important, it checks if that JSON actually matches the tool call format defined in the template for that model.
A safety check.
Exactly. If it doesn't match the expected tool call structure, it says, nope, that's just regular JSON content, and passes it through as normal text. Prevents it trying to execute random stuff.
That makes sense. That's crucial.
Definitely. And this whole approach, being incremental and template-aware, it also makes things much more reliable. They point out that sometimes, with the old method, a model might just mention a previous tool call in its explanation, right? Like it might output tool call get weather, tool call, again, just describing what it did.
Oh yeah, I've seen that happen. Models repeating themselves or explaining their steps.
Right. And the old parsers might mistakenly see that second mention and trigger another tool call.
Oops.
Yeah. But this new parser, because it's tracking the state and knows the specific start signal from the template, it's much better at telling the difference between a genuine new instruction and just a reference to an old one. Fewer false alarms.
That's huge for developers.
Yeah.
You need that reliability. Okay, let's make this concrete. The blog post had examples, right? Showing what this actually looks like.
It did. First one used CURL, the command line tool. Just asking Ollama for the weather in Toronto and telling it about a tool called Get Current Weather.
Right, and looking at the output they showed, you see done, false, meaning it's streaming. You see some text stream out, like the model thinking think, and then bam, right in the middle, this tool call section appears. With the function name, Get Current Weather, and the arguments, location, Toronto, format, Celsius. It clearly shows that tool info arriving before the stream finished.
Yep, proof positive. The parser saw the signal, grabbed the data, emitted it right away.
Then there was a Python example. They defined a simple Python function, add two numbers, passed it to the Ollama client, and asked what is 3 minus 1.
Right, and the output again shows streaming think content first. Then the tool calls bit appears. And the structure there was interesting. It was like tool call, function, name subtract two numbers, argument.
Wait, so they defined an add two numbers function, but the model asked about subtraction, actually requested a subtract two numbers tool.
Looks like it. That little detail in the output is pretty cool. It shows the model not just using the tools provided, but reasoning about the kind of tool needed based on the question. And the system streamed that decision immediately.
That's smart. Shows the model's flexibility.
Yeah, and also highlights how the Python SDK makes it easy, just passing in the function directly.
And the last one was JavaScript, right? Asking what is 2 plus 3 and defining an add tool schema.
Yep, same pattern in the output. The question, the think part streaming, then the tool call line showing the JSON function name, add two numbers, arguments, A2, B3.
So across CURL, Python, JavaScript, these examples really drive home how the parser works. It finds that tool call structure midstream, pulls it out alongside the regular text.
And this whole capability ties into Ollama's Model Context Protocol, the MCP. That's kind of their framework for managing the conversation history and state. These streaming improvements make using Ollama with MCP much more powerful.
Right, and they had an interesting side note about context size too.
Yeah, this was quite interesting. They mentioned sort of anecdotally based on their testing that using a larger context window for the model, like 32,000 tokens or more, seemed to improve things. Improve how? Both the performance, like how reliably the model actually decided to use a tool when it should, and the quality of the tool call itself, the arguments it chose.
So more context helps the model be smarter about using tools. That makes intuitive sense, I guess. It has more background on the conversation.
It seems so. Gives it a richer understanding of what's going on and what tools might be relevant.
But there's a catch, right? Memory.
Always a trade-off. Yeah, they're clear that bigger context windows use significantly more memory. So it's something you need to factor in for deployment. They showed how to set it using an option, like options, numtx 32,000 in the request.
Okay, more context might mean better tool use, but watch your RAM. Got it.
Pretty much.
So let's wrap this up. What's the big picture here? What does this Ollama update really mean for you, the listener, whether you're building this stuff or just fascinated by AI?
Well, I think the main points are, one, you can build faster, much more responsive AI applications now. No more awkward pauses waiting for the whole response before a tool gets called.
Right, that lag is reduced.
Two, the tool calls themselves should be more reliable thanks to that clever incremental parser that understands the model templates and avoids common mistakes.
Fewer weird false triggers.
And three, this interesting link between context, size, and tool use. Giving the model more context might make it better at using tools, though you need the resources for it.
Yeah, put it like this. It's a real step towards making interacting with AI feel less like sending commands into a void and more like, well, a conversation. The AI can act, use tools, and tell you about it, all happening smoothly in real time.
It feels less like a detached brain in a box and more like an active participant in whatever task you're doing. It opens the door for apps that can really do things for you more dynamically.
Exactly. So we've unpacked Ollama's streaming tool calls, dug into that incremental parser and the template magic, seen it in action with code examples, and talked about context size.
Hopefully, yeah, that gives you a solid, quick understanding of this specific technical advance and why it's pretty significant in the grand scheme of things, making AI tools more useful and integrated.
Definitely. So here's a final thought to chew on. If a model can now signal exactly what tool it needs, with the right details as it's thinking, and if giving it more context maybe makes those decisions even better, what kind of real-time, context-aware applications could you build now that just weren't practical before? Think about assistants that react instantly, or systems that need to act fast based on changing info.
Yeah, what becomes possible when that delay is gone?
Something to ponder. It feels like a capability that could unlock a whole new class of applications.